This is a very typical rate problem. That is why this is the first question that I will do with you. Let me read the question for you. If Brian can paint a fence in 4 hours and Scott can paint the same fence in 6 hours, when working together, how long will it take the two of them to paint the fence? I have seen this type of question so many times that I can't even tell you. Just the names and the variables change. Otherwise, everything else remains the same. Two machines are working together, two people are working together, two uncles are mowing the lawn, and similar questions. The formula for all these questions remain the same. The first part is to find out the combined rate. This is the first thing that you need to do. Calculate the combined rate, and in the second part use proportion. That's it, and you will be done. So what exactly is rate? Rate is basically rate equals 1 over time taken. This is something that you need to remember. 1 over time taken. Basically time taken to complete one job. This is basically rate. So let's draw a table. We have Brian. These are our variables. And we have Scott. So what are their rates? Let's say this is, sorry for this line, I'm really bad with straight lines. So the rates are, Brian can paint a fence in 4 hours. So this is 1 over 4, and Scott can paint the same fence in 6 hours. So this is 1 over 6. The rate of Brian is 1 over 4 and the rate of Scott is 1 over 6. So what's the first thing you need to do? Calculate the combined rate. How do you do that? You simply add them up. 1 over 4 plus 1 over 6. You know, you take the LCM. You've got 6, you've got 4, 2, 3, 2. I know what the LCM is, but still I am doing this calculation for you. Okay, so the LCM is 2 into 3, 6, 6 into 2, 12. Let's calculate the combined rate. 12 divided by 4 is 3, 3 into 1 is 3, plus 12 divided by 6 is 2, 2 into 1 is 2. So we have 5 over 12. Now this means that they can complete 5 jobs in 12 hours. Now you use proportion. We have got jobs and we have got hours. Very simple. If they can complete 5 jobs in 12 hours, how long will it take the two of them to paint the fence? How long? This is X, and they have to complete one job. There you go. In this, you will always have, proportion. This is our savior. I have talked about proportion at length in various chapters. You cross multiply. What do you get? 5x equals 12. X equals 12 by 5. This is your answer. Or you can say 2.4 hours. Also, please remember these formulas. They're extremely important. Rate is basically 1 over time taken. I have already talked about this. And what is basically time taken? What will be time taken? You should also know this. This is basically 1 over combined rate. These are very important formulas. And let me apply them as well. Let me explain a little bit. What is happening over here? Let's have another example. Let's say we've got two people, Ali and we have got Usman. And Ali can do a work, let's say, in A hours. So Ali's rate will be 1 over A. And Usman can complete the same job in, let's say, B hours. So Usman's rate will be 1 over B. I think this is fine so far. So their combined rate is 1 over A plus 1 over B, which comes out to be A plus B over AB. You need to remember this. This is the important part. And if I talk about time, what is happening over here? You simply take the reciprocal of this. Look at this. You simply take the reciprocal of this. So it will become AB over A plus B. These are two things that you need to remember. In the above question, I have done similar thing. I hope you don't get confused just because I've used variables a, b. This is very important. Please pause the video and absorb this for a while. Thank you guys. Let's apply these formulas on this question. Worker A can finish a job in 5 hours. When worker A works together with worker B, they can finish the job in 4 hours. How long does it take for worker B to finish the job if he works alone? So you see, the question remains the same, only the variable changes. So in this question, what are the variables that we have? We have worker A and we have worker B. So what are their rates? Rate is 1 over time taken, you already know that. So worker A's rate is 1 over 5 and we don't have worker B's rate. Let's say worker B's rate is X. That's it. So now we need to calculate the combined rate first. How do we calculate the combined rate? You already know that. You simply add them up and we know that they both can finish the job in 4 hours. So their combined rate is they can complete one job in 4 hours. This is the combined rate. The equation becomes 1 over 5 plus x equals 1 over 4. This is what you need to solve and you will get your answer. X comes out to be 1 over 4 minus 1 over 5. Remember that these are the rates, not the time. Be careful with that. Okay, you take the LCM and you get 20. 20 divided by 4 is 5. 5 over here and 20 divided by 5 is 4. 4 over here, which comes out to be 1 over 20. It means that B can do one job in 20 hours. This is job and this is hours. So our answer is D. To make your life simpler, you could have used this formula as well. This is the formula for time, AB over A plus B. Now let's have a look at this. It's so simple. AB over A plus B, where AB are the times. So A's time is 5 hours. 5 into, we don't have B's time, that is X, over 5 plus X. This is equal to the total time taken for both of these workers. That is 4 hours. There you go, just solve this. Cross multiply. 5x equals, this will go towards this side. 4 into 5 is 20 plus 4x. 5x minus 4x is x. X equals 20. This is way easier. You see, the answer is the same. This is what I wanted to tell you in this question. Now I want to move on to average speed questions. They're extremely important. There are 3 scenarios that I will be discussing in this video and they are very important. I hope you guys enjoyed the examples. Ali must be hating me by now. I'm sorry, Ali. Okay guys, let's start with a catch-up problem first. A bus leaves a station at 8 a.m. and averages 30 miles per hour. Another bus leaves the same station following the same route 2 hours after the first and averages 50 miles per hour. When will the second bus catch up to the first? These are very interesting questions and they can get very tricky and confusing as well. So to make your life simpler, I just use one table for all these problems. For the catch-up problem, motion in opposite direction or the round trip problem, just use this table and that's it. Do not get involved in multiple variables or simultaneous equations. It will get difficult. Let me show you how I will approach this question. So we have the variables. Let's say we have train A and train B. Okay. Then we have rate and into time equals distance. This is the table that you need to fill every time. That's it. This is what I'm going to do. Okay, so let's start now. We have train A, which averages at 30 miles per hour. This is the rate. And train B, which averages at 50 miles per hour. Okay. The trick to using this table is always have one variable only. That's it. As I said, do not involve multiple variables or multiple equations. Let me show you what do I mean by one variable. So let's say it starts at 30 miles per hour and travels for X hours. Okay. Now train B, it starts after 2 hours. So it traveled 2 hours less than this. It traveled for X minus 2 hours. This is the trick. See, there's only one variable involved. That's it. Now you calculate the distance. They both travel the same distance. Let's say this is train A, this is train B. So let's say they both catch up over here. They both travel the same distance. D1 equals D2. Remember? Okay. So train A traveled 30x and train 2 traveled the same distance, which is 50 into x minus 2. We will always play in terms of distance. That's our key. So in this scenario, D1 equals D2. So 30x equals 50x minus 100. Do the calculation. You will get 20x equals 100 and x equals 5 hours. So train A basically traveled for 5 hours before train B caught up to train A. That's the answer. So you will add 5 hours to this and then we will get our answer. 8 plus 5 is, we have 13, which means that at 1 p.m., train B caught up to train A. That's it. Let's have a look at motion in opposite direction example. John and Philip, who live 14 miles apart, we have the total distance, start at noon to walk toward each other at rates of 3 miles per hour and 4 miles per hour respectively. After how many hours will they meet? We do exactly the same thing. We draw our table. We have our variables, which are John and Philip. Then we have the rates into time equals distance. So see, this remains the same. Nothing changes. Let's just fill the table and that's it. In this scenario, their distances will add up to 14 miles. That's the trick. So let's say John starts from here, Philip starts from here. Let's say they meet somewhere here. So D1 plus D2 equals total distance. This is the trick. Okay, so John's speed is 3 miles per hour and Philip's speed is 4 miles per hour. They both start at 12, so they travel for the same amount of time. Let's say this is x, so this is also x. See, one variable. Distance traveled by John is 3x and distance traveled by Philip is 4x. So you add them up, what do you get? 3x plus 4x equals total distance, which in this scenario is 14. 7x equals 14, x equals 2. They will meet each other after 2 hours. Let's have a look at a round trip problem now. How far can Scott drive into the country if he drives out at 40 miles per hour and returns over the same road at 30 miles per hour and spends 8 hours away from home, including a 1 hour stop for lunch? Interesting. We will use the same table. That's the trick. We have our variables. Rate into time equals distance. That's it. Let's fill the table. I'll just add arrows for, let's say he's driving into the country, he's going into the country, and this is he coming back. So the rate at which he's driving into the country is 40 and the rate at which he's coming back is 30. You can also draw a figure just for your own ease. Let's say he starts from here, he goes into the country and then comes back via the same route here. This is Scott going into the country and this is Scott coming back. Now the trick is the time, and you know we have to use one variable. Let's say the time that he traveled while going into the country is x. Then what will be this time? This should be 7 minus x. Why 7? Because his total traveling time is 7. He stopped for 1 hour for lunch. So he traveled for a total of 7 hours and not 8 hours. This is the 7. And if the time that he took while traveling into the country is x, then the time that he came back while traveling out of the country should be 7 minus x. Very simple. You just subtract this from the total. So this is x and this is 7 minus x. Now you calculate the distance. This will be 40x and this will be 30 into 7 minus x. Now you know the distances are equal. d1 equals d2. 40x equals 30 into 7 is 210 minus 30x. So 40 plus 30x is 70x equals 210, x equals 3. But we are not done yet. Please look at the target answer. The target answer is how far can Scott drive into the country? So we have to calculate the distance. You can calculate either this or this because both are equal. This is simpler, so I'll replace x with 3 and 40 into 3. The answer is 120 miles.